So yes, domain is hard, but we've been doing this. What's the excluded value from the beginning, right? Yeah. And so you're quite good at being able to see that. Well, now it's not just the excluded value. It's the same thing as what's the domain. Okay, so they're one and the same. So when we have a fraction like that, this is called a rational fractional expression, which will be coming up after this test. Denominators tell us about domain, denominator domain, okay? The only other thing that we have to be careful of right now at this point in time are root functions. So if I give you a square root of 2x plus 1, and I ask you what's the domain of this function, how do we figure out the domain of that square root function? Is it equal to 0?
Or like,
No, it's
Greater than or equal to 0. Yeah, the inside. Why do we take the inside and say you must be greater than or equal to 0? We can't take the square roots of negative numbers. So we say you got to be 0 or more, right? All right. So also, when in doubt, graph it out. You know this is a square root swoop. So you can always plug it into your calculator and take a look. All right. And then this is an equation we can solve. 2x must be greater than or equal to negative 1, which means x is greater than or equal to negative 1/2. And that is also the domain. So right now, these are the only two things that you have to pay attention to. Denominators and roots. And if just playing with some scissors, it's good. Okay. Every parent's worst nightmare. Okay. So, right now, domain seems very hard because we have overlapping domains as well. And so when you have more than one thing to look at, I'm always going to go to make a little sketch of what you're looking at and where do they overlap. And if you can do that, then domain shouldn't be a problem. Today, we have composition. So right now, you should have written these two things down. This is a composition of functions. This is read f of g, f of g. It's a little circle, all right? And we would literally say f of g. And then here, I would read of x, or in terms of x. And so if I were to read this whole statement, it would be f of g of x, or f of g in terms of x. And this is the old school meaning, where we have our f function, and what we're doing is we're taking our g function and actually plugging it into the f function. We're putting one function into another function, kind of like a turducken.
Turkey, chicken.
turkey. It's a turkey stuffed with a chicken stuffed with a duck.
A turkey, and inside it you put a duck with the chicken inside the stuff.
Wait, the chicken goes inside of the duck? I thought the duck went
Yeah,
inside of the
turducken.
Oh.
Turkey,
wow.
duck,
I was
chicken.
like really confused. I'm like,
Turducken.
turkeys are smaller than ducks.
Yeah. So, turducken, yeah. So it's basically, it's almost Thanksgiving. That was totally appropriate.
I wonder if
Okay.
people really eat those.
It
How
would make
can you
me barf.
safely
I don't
make
know. All right. Okay, this is the really important part. F of g of x. We're going to use this notation most of the time. And I'm going to show you how to apply that notation. The domain is very complicated. So that's why I said write this down. Record. Write this down. The domain of the inside piece, whatever's on the inside, right here, g of x is on the inside of the function. It's inside the f. Okay, so, and the resulting function. So we're going to figure out what f of g of x is, and we have to compare those two domains. So this is that mathematical and where it has to work for both, the overlap of the two domains. Okay. This is really complicated stuff we didn't used to teach. I would say it takes a lot of years to really understand why. Right now, I'm just sort of telling you, but it takes a long time to really understand. Okay, so let's just see how this works today. Here we go.
Oh, no.
Oh, yeah. Oh, yo. Okay, this isn't like that.
Yeah, I don't just talk about math. I actually make you do it.
Aw,
Oh, yeah. I wish we could just talk about things and then know how to do it, but it just doesn't work that way.
I wish it did too, honestly. That would be so convenient.
Yeah, but man.
Find the following and the domain.
What?
What?
No.
We don't just talk about being kind. We actually need to do it.
Yeah, you gotta.
I get you.
Practice.
Oh, that's what you meant? Yeah. I guess that's
Each night.
Okay, how we doing?
Gotta be cool.
Yeah,
be
keep
kind. What is that song?
I don't know.
Cool to be kind?
Probably.
I'm not doing
Is that a garbage song? I'm seeing like, oh, what's the movie with Heath Ledger and
Oh, not for sure.
10 Things I Hate About You? No, yeah. I'm sorry, we're listening to my conversation with him. Okay, here we go. I'm gonna do math now because I'm sure you've written all this down. All right. A composition, plugging one function inside of another. Right here we have f of g of x. And what that really means is f is on the outside. And we're going to have on the inside, this inside function is g of x. Well, what is g of x equal to? X plus 1. So can I say, hey, I know what g of x is. G of x is x plus 1. Can I do that?
Yeah.
Yeah?
I don't
Cool, thanks. All right, so that was step 1. So now when I look at this notation, what is this notation telling me to do?
Plug into
Distribute that.
I don't know.
Put that into the
Yeah, this is gonna, look, it says, hey, go to your f function. There's the f function. But you don't have an x anymore. What are we gonna have instead of x?
X plus 1.
X plus 1. So everywhere there's an x, so we have our 2x squared function. Now instead of the x, what are we using? X plus 1.
I do not understand.
This says go to the f function. So there's the f function, 2x squared. And you're not using x anymore. We're using x plus 1 now. Okay, we're using x plus 1. Where there was an x, we use x plus 1.
Is this like the G for F or F for G instead of writing G of it or like that? Because that would tell you directly what you're doing, and then
I'll have to think about that.
Is this like the replacing thing that we
Yes. Yeah, it's very similar. So
after really
replacing.
catching up?
I know. Yeah, it takes a while to figure that out. What do we need to do first here?
X plus 1 times X.
X plus 1 times x plus 1. Yes, we've got to square that thing. What is x plus 1 times x plus 1?
X squared plus 2x plus 1.
Good. And now there's a 2 that we have to multiply in. 2x squared plus 4x. I knew it. Plus 2. That is f of g, and that's not fog. That's f of g.
Oh, that is.
That's it. That's the resulting function, but we also need to figure out the domain. So the domain is the domain of the inside piece. The domain of our inside piece is g of x. So I'm going to look here. That's g for g of x. This g of x function is what shape? It's a line, right? Mm-hmm. And so what's the domain? Negative infinity to positive infinity. Okay. So let's just say it's like the whole line. Good. Okay. So I just made a sketch. And then we also need to compare that to the domain of the result. I'll write that in blue. Domain of the resulting function. result. This is my result right down here. F of g. What shape is this function? Parabola. Right? What's the domain of a parabola? Negative infinity all the way to infinity. Okay. And the domain is the intersection of both of these things. I haven't used that word before, intersection. It means the overlap. Okay. So where do they overlap? Everywhere. Yeah. All the way from negative infinity to positive infinity. That is the domain of this function. Kind of weird.
That's a lot. Whoa, my God.
So, whatever the domain is for each, like if they match, then that's the domain.
Yes, if they match, that's the domain. Yes. Yeah. So it's nice when the domains match. But like I said, it's typical. The domain is the the smaller of the domains, whatever the smallest subset is. All right, g of f of x. Do you think it's going to be the same? No. 99% of the time, it's not going to be the same. 4 plus 5 is the same as 5 plus 4, but this is not addition. Okay.
Whoa.
It's just back to addition.
G of f of x. So this is g of f. This is what it means. G of f of x, where f of x is on the inside. Okay. What can I replace f of x with?
2x squared.
All right. F of x is the same as 2x squared, so I substituted. Now, what is g of 2x squared telling you to do?
So x plus 1
Yeah,
times
2x.
2x squared.
I can explain this.
What 2x
Go
squared?
for
X is
No,
equal to
No. Go to the g function.
x.
Are we using x?
Yeah.
Yeah.
Oh,
No,
yeah.
we're using 2x squared. Okay. So wherever the x was, we're not using x anymore. We're using, in place of the x, 2x squared. So instead of x plus 1, it's 2x squared plus 1.
Is this gonna be on our test?
Yes.
Oh my god.
Is the thing
This
that it's
is-
like
Is this gonna be a test?
Yeah,
Yeah,
did
it is.
Friday get a test? I didn't.
Well, you got a couple more days to figure it out.
Are you sure?
G of f. I'm totally sure I just wrote the test this morning. No.
Oh, wait, that's it?
But yeah.
That was hard.
Why do you guys keep
But
saying
that-
that?
Sometimes when it goes on, I think
That was
it's gonna get
very
worse,
easy.
but this doesn't seem.
Okay, so domain.
Wait till you see example.
It's infinity.
What's the, it is, yeah. What's the inside function?
It's the FX.
F of x is the inside function. There it is in the inside. And what's the domain of that f function? Yeah, the shape is, it's a parabola. And so you know it goes from negative infinity all the way to positive infinity. And then we want to look at the resulting function, g of f. And we look at that, and what shape is that function? It's also a parabola, so it's going from negative to positive infinity. Both of these go from negative to positive infinity. And so they match. So the domain of the whole thing happens to be negative to positive infinity. All right? So I think you're starting to understand that shape has a lot to do with domain.
Yeah.
It's really good.
It makes
Okay.
it easier to know.
Mm-hmm. So this one was easy.
What are you doing?
All right.
Why?
Given f of x equals 3 over x minus 1. And g of x equals 2 over x.
Oh, my God.
Find g of f of x and the domain. So before I do anything with this, I want to talk about the domains just of these basic functions here. So before I even worry about my composition, as in composition like a musical score, composing,
Right, you know this.
Yeah. So what's the domain here of f of x? What is x not allowed to be? Good. 1. Very good. So that's the domain of that one. And what about here? X cannot equal 0. Good. Okay. So right off the bat, we have some exclusions here. All right. So we want to find g of what's on the inside? F of x. Good. All right. So that's the proper notation. And what can I replace my f of x with?
3 over x.
Good. 3 over x minus 1. Good. And now what does g of 3 over x minus 1 tell you to do? So go to your g function, which is way over here, and we're not using x anymore. So I have 2 over something. What am I putting in place of the x? 3 over x minus 1. Very good. Okay. All right, well, that's a complex fraction. How do I clean that up? Keep, change, flip. Very good. Keep, change, flip. If you needed to get common denominator, you might need to do that. But this one is all nice and sort of tight, compact. So we're going to keep the 2, change the division sign to a multiplication, and flip our fraction, which becomes x minus 1 over 3. Keep, change, flip. And that's going to give me 2x minus 2 over 3. That's kind of interesting. All right. That is g of f. That is the resulting function right there. What's the domain of this function? What shape is it? Ooh, that's a trick question.
It's a line.
It's a line. It is a line. Another way we could rewrite that is 2/3 x minus 2/3, right?
Oh.
Oh yeah, it is just a line, right? So this domain goes from in negative to positive infinity since it is just a line. But I like drawing my domain out. So, and this is what happened to it is it flipped. Keep, change, flip, so that we could clean it up. And this is why composition, the domain.
Yourself, like it wasn't unnecessary.
If you have a complex fraction, you should simplify. Yeah. So, so this is where composition of functions get complicated because it looks like the domain goes from negative to positive infinity. So that's actually incorrect. It cleaned up real nice, except for the fact that what we started with had exclusions. So that's where the domain becomes very tricky. So remember, when we want to find the domain, we have to look at the inside function. What was the inside function? 3 over x minus 1. And we knew that that had a domain where x could not equal 1. So I'm going to draw that. There's 1. Open circle because we're not allowed to equal it and everything else works. And then our result was down here, which we said was a line, and it has a domain from negative to positive infinity. The domain is actually the intersection of both of these. What works for both parts?
The first one.
From negative infinity all the way to 1.
Oh no.
And 1 to infinity. Okay, so it's what overlap works for both of them. And this is the actual domain of this function. Yeah, you can. There could be multiple things that you. Yeah.
Just to verify, let's say we're finding g of f. Anytime there's an x in g, we put f.
The f function in.
Okay.
Yeah.
F of G is anytime there's an X in G.
Yeah.
Please tell me this is it.
Yes. Yes. So another way, So another way you could write this is we could say X is not allowed to equal 1. These two things mean the same thing. These two statements. So this is the short way. This is the longer way. This is they both don't work here. This is the comparison because this looks really nice and neat. Easy domain, but it actually came from something that had a smaller domain. So we have to go with a smaller domain. Okay, let's try another.
Another?
Yes.
Is this the last one?
Wow.
Please say yes.
Yeah, this is the last one.
Yes.
Yeah, this is the last one.
Alright, let's take it over. Let's do this.
Let's do this. Let's do this.
That's a Black Eyed Peas
Oh
song.
yeah. That's okay.
Who is speaking
And
out?
she started singing it and it went in my head.
Okay. F of x equals the square root of x, and g of x equals 2x minus 1. We want to find f of g of x and the domain. And I think on your homework you have to do both of them. So you don't have a ton of problems because each one is like 2 problems in its own. All right, someone's having too much fun in class.
I don't think
So once again, we have, I don't know why this is written over here. That's really irritating. 2x minus 1. Okay. I want to look at the domain here of f of x. What's the domain of our function here? Yeah, the lowest x value is 0, or x must be greater than or equal to 0.
How do you get that?
The inside always has to be greater than or equal to 0. Every square root. Always. Square root swoop, right? What does the swoop look like? Swoop, and it starts at 0, 0, right?
Yeah.
Yes. Okay. So our picture is everything to the right of 0. And what's the domain for our g of x function here? What shape is that? It's a line, right? And so how far left and how far right does that go? Negative infinity to positive infinity, yes. This is inequality. We could write 0 to infinity if we wanted to. It's another way to write that. Okay. We want to find f of, what's on the inside? G of x. All right, what can I replace my g of x with? 2x minus 1. And then, now what is this command telling you to do? F of 2x minus 1. What does that say? Go to your f function and plug in 2x minus 1 in place of the x's.
He's putting in math. He knows what he's doing.
So instead of my x, I'm using 2x minus 1. And that's all we can do there. That's f of g. That's our result.
Wow.
Yeah, that's kind of nice, right? So again, for the domain, I need to look at the inside function and I need to look at the result and compare where it works for both. So this is the process for domain. What's the inside function? 2x minus 1 is on the inside, and we already said the domain was negative infinity to positive infinity. Negative infinity to positive infinity. Very good. Then we look at this resulting function here. It's under a square, it's a swoop. And because it's a square root, what do we know about it? Must be greater than or equal to 0, which means greater than or equal to 1/2.
Except it can't be equal to 1/2.
Yeah, it's
Well, for this particular one, but grand scheme of things, it can't
No one's asking about the grand scheme.
equal. Alright.
So
So
That's only good for
Check
Jeff,
this.
I wanna
Wait
go
a second.
back.
Gotta give me-
so what works for both?
Oh, is this good? Yeah, there you go.
1/2 to infinity is where they both overlap.
There.
That is
Oh.
the full domain.
What the?
1/2 to infinity, including the 1/2. All right.
That's the last one we hear.
Okay.
You're a
All right, ladies and gentlemen, you've got the next half hour and a bit to work on 72.
Hold on.